We've had some interesting sessions from the morning, and I've been sitting behind and taking notes. We spoke about cloud, we spoke about green IT, we spoke about problems that a company went through with adopting cloud, trying to sort of leverage the benefits of cloud, outsourcing some of the critical applications to a cloud provider. And there was also some amount of reality in a cloud provider going bust, and the company trying to retrieve business, as he put it, and the data, and the worries around why a cloud provider would not delete data, or what would you do with that data, and all of that stuff. So it's been a lot of logical stuff that we spoke about in terms of assuming that the building blocks exist, which is the networks, the data center, and they deliver all the time, and they're available 24/7. And on that, we have hardware which is running, and we also spoke about consolidation, right? We said we have enterprises which run on 6 servers and 8 servers and virtual machines and move everything in there. Difference between what is virtualization and what is cloud and all of that. A lot of interesting stuff. The building blocks are data centers and network. So I thought when I looked at the agenda, I should talk about, and of course we had a very interesting presentation in the morning about largest data centers from Yahoo, Google, how to optimize on power, why are they power hogs, and how to look at building efficiencies and all of that. So I thought it's good to quickly jump into data center design considerations. There's a whole lot that goes into building a data center that runs all this cloud, private cloud, public cloud, hybrid cloud, or cloud data centers, the jargons that we hear around data centers, right? So we consider when we've all been associated with some data center in some form, either leased or either owned, or either completely built out from grounds up. So we've all been associated with data centers, and we've gone through complexities around what's the location going to be like, is it a good catchment area for good labor, is it a good place to have data centers, is it well connected, all of that stuff. And then we go through building and say, is it located in a good location, is it reachable, and is it like having good floor plate, what is the column width, can I bring in machines, what is the freight lift looking like, or what is the goods lift looking like, is the corridor well maintained. We worried about various things that relate to a building. Are there 2 entry paths for fiber? Are there many service providers in your facility if it's a co-located facility, or if it's your own facility, try and get as many providers in as possible. So we've done all that just to make sure the applications, the data that we use is available 24/7, and it's not disrupting business in any way. And then we've talked about power supply, power density. Unfortunately, in India, we don't get the power redundancies that you get in other countries with 2 different providers and all of that. You tend to do as much as you can with power diversity. Then we worry about cooling systems, security, fire safety, etc. So there's so much to worry about when it comes to the basic building block. And I think there was an interesting observation that was made in the morning presentation where somebody said having 2 tier 2 data centers in 2 different parts of the globe is probably better off than a tier 4 data center. And the buzzword in data centers today is tier 4 data centers. Build in redundancies, talk about how well we can handle failures, and at the same time there's a price that you pay for a tier 4 data center. And tier 4 typically means 2 different power supplies from the grid level, which is close to not being possible in India, considering the way we are organized in the power distribution sector. So moving on, saying this is just a partial list of what we go through in a data center, right? We also talk about maintenance, management. There are standards around maintenance and operations that are evolving right now. There are practices, that people recommend around data centers. So how to run your data centers well. What are the processes that you should follow and all of that. So what are successful data centers? So a successful data center is a data center that's available 24/7 and is able to sort of provide services to all the upper layers that depend on the data center, which is the private cloud, public cloud, all of that you spoke about. So what is the ask of the successful data center? It should be flexible and scalable, which means that I should be able to increase power densities as the data center, power demand goes up, which means when I virtualize, when I consolidate, I expect my power, per rack to go from 3 kilowatts a rack to 20 kilowatts a rack. There are racks that consume that kind of power in India today, and there are customers who are virtualizing, consolidating, and thereby asking more of data centers, which they either operate on their own or in co-location facilities. So the reason why I put these two slides up there is that it's not simple these days to run a data center the way it used to be, because technologies have become complex. The cost of running data centers, the cost of managing data growth is increasing, and thereby we constantly ask ourselves the question, are we efficient? Are we running a cost-effective service? Are we providing a cost-effective service to our own businesses? So when you start doing that and then start asking questions around, is my data center flexible? Is it scalable? Can I add to it? And all of that, you have design considerations which probably may not have been completely, addressed, in the earlier part of the, data center build. And then when you, sort of move on to try and use that data center for different purposes, then, you're faced with challenges around flexibility and scalability. We all spoke about virtualization, data consolidation, and one interesting thing that, I didn't observe is, worries about data growth. The fact that we are doing all of this, we're facilitating ease of use, we're facilitating IT IT services to be consumed more as a service. Like somebody mentioned in the previous session that you become a service provider for your organization and thereby make it easy for your end customers to use more of IT services. And like, for example, each one of us have 3 or 4 public email accounts. So we all generate data in some forms. We all receive mails. So there is data that's constantly growing on the internet, and the ease of growing data is very, very high. And data growth, virtualization, and consolidation are like 3 factors that are at play, increasing the demand for quality data centers, and the fact that some of these technologies are being adopted very aggressively means different ways of looking at data centers now. Earlier, about 5 to 10 years ago in India, people used to talk about how much floor space do I get in a data center, or how big is my data center. Today, people talk about I have 6 servers which consume far less power than what I used to consume earlier. But can I use the space that I freed up because of all these consolidation activities? Maybe not, because there isn't enough power in the data center to probably use that space as well. So then you become constrained. Can you go and upgrade power in a facility which is leased or which is being operated by somebody else? Probably not. So these are questions which we ask and which get asked of when we start demanding more of our data centers. So I thought I'll talk about some fun facts on data growth. Every time we go to an e-commerce site and do a transaction, we are adding to somebody's data. Every time we tweet, we are adding to data on the internet. Every time we go watch a YouTube video, we're putting some pressure on the network, some pressure on the data that's being accessed from somewhere. And when you contribute a video, you obviously add to data growth. And this base is only growing, right? Now you have the younger generation wanting to have a phone with Facebook, Twitter, email capabilities, and all of that. So you're adding to data constantly. And data centers become the backbone, taking all of this load. And there are roughly about 500,000 data centers across the globe. And this is an interesting fact that I picked up. And if it fails, there's a lot at stake for all of us here in this room. So how do we sort of address all of this and understand and sort of make choices around data centers? Data grows at roughly 25 to 50% every year across all of, when I say data, it's internet data, IT data, all of that. And each one of us are trying to archive, make sure that we are having only the most recent data, but we can't throw off the archive data as well. Increased Power density because of virtualization. I spoke about it, 3 kilowatts to 20 kilowatts to 40 kilowatts. We ask more of the per square foot power that we get in a data center. And then our storage boxes. I saw some anti-vibration racks or cabinets for data center storage, systems being spoken about in the morning. The storage systems that we have, and earlier when we used to say we have a terabyte of data in our data centers, we all used to feel proud. And today we have multiple terabytes, of data in our data centers, and they consume a lot of power. So there are various, reasons for data, to grow, and various reasons for us to ask more of our data centers. And we all ask this question: is my current data center, is my current facility where I'm sitting in, future-proof? Can I take this data center to 2015 or 2017, and would I be able to answer all the needs of my business? That's a question that we ask ourselves. So 3 questions to answer when you come to that point around build or buy. Do I enhance my existing facility? Do I retrofit my facility and get more of it? So what would be the cost that the company would incur directly or indirectly? Whether it's like and the business is able to take that spend around either a capex item or an opex item. That helps us decide whether we should build or buy. What are the benefits of building versus co-locating in somebody else's facility? What are the risks associated with either doing a build or a buy? Economic uncertainties and the impact of running, a data center, for your business. Like, you invest. There are customers that I have seen personally who have, data center space which runs into 100,000 square foot for a particular enterprise. And today they think they built it over a period of 10 years and 15 years, and today they think it's a liability. Today they think it's something that probably they can better spend on something else to be more agile. And thereby look to service providers who say, can you take my entire data center and run? They want to outsource infrastructure that they held close to their heart over a period of time, and realize that that's become a probably not a very wise investment, because it's expensive to maintain data centers and invest in data centers, because they constantly need upgrades and need investments. So they come back to service providers and say, can you take it and run? So think about benefits of co-location, leasing a data center versus building your own. Building your own definitely has a lot of advantages. You get complete control, very little risk of losing your lease, or very little risk of people asking you to vacate. But it's a sunken investment. It's a sunken cost, and you need to worry about all those design criteria that I spoke about. And it is not that they get fixed once and then you don't need to go and relook at them. Technology around the physical infrastructure, which is what I would call the data center, is constantly changing, and you need to sort of understand the newer ones. I run the constantly learn, because every time I look up some information for something, I constantly find new developments, because we're continuously striving to improve efficiency of a data center. On the other hand, you have the choice of leasing a data center from a data center provider, where power densities can go up. You can dynamically ask for space. You can dynamically ask for skills around it. There is a lot of experience that goes into building and maintaining data centers. So these providers have the data center capabilities. And there's also an ecosystem of probably partners, like the cloud service providers that you spoke about. They probably sit in the same co-location facility as where you co-locate. So network is another key component of the cloud. It's invisible. People assume that the last mile problems get resolved with cloud. You still have the same access challenges with cloud. Cloud isn't anything vastly different from what we've seen in the past. It's an evolution of various technologies. That's the way I would see it, and somebody summarized it very well. Private cloud, public cloud, hybrid cloud, how these things sort of stack up, and commonly misunderstood as software as a services cloud. So it's like various assumptions around cloud, but the underlying concepts are data center, network, the problems around running efficient facilities. So when you look at co-location services, providers, probably they give you the benefit of managing all of these variations for you cost effectively. So a little bit about the business that I run. It's global data center and co-location facilities from Tata Communications. We have 42 facilities across the globe. This is backed by an undersea submarine cable network that we have. We own and operate the largest undersea submarine cable network, and all our facilities are cable heads, which means you get the shortest path into the submarine network. And we have roughly about 300,000 square foot of data center raised floor space in India, and we're planning to treble that space based on the data growth that we understand, based on the virtualization, data center consolidation driving up requirements. These are high power density facilities that we're building, and we will treble that space in probably the next 3 to 5 years time frame. So that's all I have. It's a thought that I thought I should leave with all of you, considering that we talked about the latest technologies around cloud and virtualization and all of that. And I said, let's remind ourselves of the fundamental building blocks, which is network and data centers. Thank you very much for your time and attention.